Right now, as you are watching this, nuclear reactors in France have been throttled back because the rivers that cool them have gotten too warm to safely absorb their waste heat. A wildfire is burning near Paris, Barcelona's oldest weather station, a site that has been keeping continuous records for 112 years, just logged the hottest temperature in its entire history. And this is not the first time this has happened this year. This is the third time in 3 months that the exact same atmospheric pattern has locked itself over Western Europe and simply refused to move. Scientists have a name for what is happening above all of our heads right now, and it explains almost everything about the wild, stuck, record-shattering weather. The Northern Hemisphere has lived through this year. The jet stream, the high-altitude river of air that normally keeps our weather moving, has broken its usual pattern again, and researchers studying it are increasingly blunt about what that means for what comes next. Today we are going to break down exactly what a broken jet stream actually is, why it keeps happening in the same dramatic way, and what the real science, not the panic headlines, says is coming. Drop a comment right now and tell me what the weather has actually been like where you live this year. Hotter, wetter, stuck in some strange pattern, or surprisingly normal. I read these, and I'm always curious how differently this is showing up around the world. If you want grounded, sourced breakdowns of what is actually happening to our weather, subscribe. It is free. And a like helps this reach people who need to understand this rather than just panic about it. Let us go for 5,000 likes on this one. Thank you. Now let's get into it. To understand why this keeps happening, you first need to understand what the jet stream actually is. High above the surface of the Earth, somewhere between 8 and 12 kilometers up, there's a narrow ribbon of extremely fast-moving air that circles the entire northern hemisphere, sometimes reaching speeds close to 400 kilometers per hour. Its job, in simple terms, is to separate the cold air sitting up near the pole from the warm air sitting closer to the equator. And in doing so, it acts like a steering current for nearly all of our large-scale weather. Storms, fronts, cold snaps, and heat waves all get pushed along by this current under normal conditions, which is exactly why weather in most places changes every few days instead of sitting still for weeks at a time. Under healthy conditions, the jet stream flows in a fairly straight line, west to east, like a river moving briskly through its banks. But for at least a couple of decades now, scientists studying satellite and weather balloon records have documented something changing in that river. It has been slowing down, and as it slows, it has started to wobble more dramatically, forming large looping waves instead of a straight path. Occasionally, one of those waves gets so large and so pronounced that it locks into place entirely, forming a shape that meteorologists have started referring to using the Greek letter omega, because on a weather map, the pattern genuinely looks like the letter itself, a tall arching ridge of high pressure with 2 dips of lower pressure omega block, and it is the single mechanism behind almost every major heat wave that has broken records across Europe this year. Here is why an omega block is so dangerous compared to ordinary hot weather. Under normal summer conditions, even a hot spell gets pushed through by the jet stream within a matter of days because the jet stream keeps dragging fresh weather systems in behind it. When an omega block forms, the jet stream instead bends around that high place, sometimes for a week, sometimes for considerably longer. With no frontal system able to push through, skies stay clear, which means there's nothing blocking the sun from heating the same patch of ground day after day after day. Each additional day under a stalled ridge adds more heat on top of the heat already baked into the soil, the buildings, and the pavement from the day before, which is exactly why the worst days of a heat wave usually arrive toward the end of the block rather than at the very start. This year gives us an almost textbook demonstration of exactly how destructive that mechanism can be, because it has happened 3 separate times already. The first wave arrived remarkably early, starting around the 22nd of May, according to weather tracking records, and it broke springtime and May temperature records across Portugal, Spain, the United Kingdom, Germany, France, and Ireland, with the town of Mora in Portugal recording 40.3 degrees Celsius on the 27th of May, an extraordinary number for that time of year. 11 deaths were recorded during that first wave alone. Climate scientists at the time were already noting that this kind of early season, record-breaking heat had climate change written all over it, contributing to an earlier and more intense start to summer than the region has historically experienced. Then, starting around the 20th of June, the pattern reformed, and this time it became what multiple meteorological outlets described as one of the most severe heat events Western Europe has ever recorded. A heat dome sustained by another omega block pulled superheated air directly off the Sahara Desert and parked it over the continent for days, pushing temperatures between 14 and 18 degrees Celsius above normal for late June, from Portugal all the way to Poland. The numbers that came out of that event are genuinely staggering. Andejar in southern Spain recorded 45.1 degrees Celsius on the 22nd of June, a new benchmark for the entire Iberian Peninsula. Germany logged a provisional national record of 41.7 degrees Celsius. France recorded its highest temperature since national records began in 1947, with the thermometer hitting 44.3 degrees Celsius. According to the European Center for Medium-Range Weather Forecasts, June of this year became the hottest June ever recorded for Western Europe, with an average temperature 3.06 degrees Celsius above the 1991 to 2020 baseline. More than 50 deaths were recorded in France during that single wave, and more than 40 of those deaths were people who drowned while seeking relief in unsupervised rivers, lakes, and canals. Thousands of homes lost electricity as power grids strained under the load of air conditioning demand they were never fully designed for. And then, rather than easing off as heat waves typically do once a block finally breaks down, the pattern reloaded again in July. Barcelona's Fabra Observatory, a world meteorological organization, long-term monitoring station that has kept continuous records since 1914, recorded 40.5 degrees Celsius on the 8th of July, the highest temperature in its 112-year history. And just in the last day, France entered its third distinct heat wave of the summer, forcing multiple nuclear reactors to reduce output because the rivers that supply their cooling water had warmed to the point where releasing that heated water back into the ecosystem risked serious environmental damage, while a forest fire broke out near Paris under the same tinder-dry, high-pressure conditions. 3 separate omega blocks, 3 separate record-shattering heat events, all within the span of about 7 weeks. That is not a coincidence, and it is not simply bad luck. It is the same physical mechanism firing again and again because the underlying conditions that produce it have become more favorable. This is where the actual science gets genuinely important rather than just alarming. A team of researchers, Dim Kumau and Ray Chemke, published a study demonstrating that human-caused climate change was the primary driver behind a significant weakening of jet stream wind speeds between 1979 and 2020 during the northern hemisphere summer specifically. That matters because it was one of the first pieces of research to directly connect human-driven warming to a measurable physical weakening of this specific atmospheric current, rather than just noting a correlation. Separately, a research team led by University of Arizona geoscientist Matthew Osman reconstructed North Atlantic jet stream behavior all the way back to the 8th century using ice core. Records from Greenland, published in the Proceedings of the National Academy of Sciences, their reconstruction found that despite dramatic warming in recent decades, current jet stream variations still fall within the range of natural historical variability, at least for now. But their modeling also projected that under continued unabated warming, the jet stream is expected to migrate progressively northward and become distinctly different from anything in that natural historical range by around the year 2060. In plain terms, we may currently be watching the transition period itself, the years where the pattern is still technically within historical bounds, but is very clearly straining against them. The mechanism behind the weakening itself comes down to something called Arctic amplification. The jet stream exists in the first place because of the temperature difference between the cold air near the pole and the warmer air near the equator, and the strength of that temperature difference is essentially what powers the current, the same way a bigger difference in water pressure powers a stronger flow through a pipe. But the Arctic has been warming considerably faster than the rest of the planet, which means that temperature difference, the pressure driving the jet stream, has been shrinking. A weaker temperature gradient produces a weaker, wobblier current, and a weaker, wobblier current is far more prone to forming the kind of large, slow-moving waves that eventually lock into place as omega blocks. Studies looking at Arctic ice loss between 1979 and 2022 found a measurable correlation between the retreat of sea ice and the intensity of jet stream oscillations, meaning the loss of ice at the pole and the increasing waviness of the jet stream are not separate stories. They are two symptoms of the same warming climate system. Here is the part of this story that should genuinely change how you think about heatwave headlines going forward. The World Weather Attribution Group, a multinational collaboration of climate scientists who use peer-reviewed methods specifically designed to calculate how much more likely a given weather event was made by human-caused climate change, conducted a rapid analysis of this year's European heatwaves. Their conclusion was about as direct as climate science gets. They found that heat waves of this intensity would have been virtually impossible without human-caused climate change, and that events like this are now roughly 200 times more likely than they were just 2 decades ago. Samantha Burgess, the strategic lead for climate at the European Center for Medium-Range Weather Forecasts, described the findings as reflecting a climate system that is continuing to accumulate heat, and specifically warned of increasingly intense heat waves, a persistently warm ocean, and growing risk to people, ecosystems, and infrastructure. That is not a media outlet dramatizing a headline. That is one of the continent's leading climate scientists describing in plain language exactly what the instrument data is showing her. It is worth being honest about the uncertainty here too, because overstating scientific certainty is exactly the kind of thing that erodes trust once viewers start comparing claims across different channels. Scientists are not saying that every single heat wave from now on will be caused by an omega block. And they are not claiming that omega blocks themselves are a brand new invention of this century. The 1947 Fabra observatory record that Barcelona just broke this July shows that extreme heat events have always been part of this region's history, and researchers studying the famous 2003 European heat wave, one of the deadliest weather events in modern European history, identified the exact same omega blocking pattern behind it more than 2 decades before this year's events. What has changed is not the existence of the mechanism. It is the baseline temperature the mechanism is now operating on top of. Every fraction of a degree of background, global warming raises the ceiling on how hot an omega block-driven heat wave can ultimately get, which is precisely why readings that would have been unthinkable a generation ago, numbers like Germany's 41.7 degrees Celsius, now arrive during what is technically still described as an early summer heat wave, rather than the absolute peak of the season. It is also worth understanding that a weakened, wavier jet stream does not just produce heat. It produces extremes in both directions, depending entirely on which side of the wave a particular region happens to sink, T under. The same loss of Arctic sea ice that researchers have linked to a wavier jet stream has also been connected in separate studies to unusually sharp cold air outbreaks reaching much further south than they historically would, essentially allowing pockets of Arctic air to spill downward through the dips in the wave pattern at the same time that other regions bake under the ridges. Meteorologists have also noted that as the jet stream retreats further north through the summer months, tornado activity in North America tends to shift accordingly, favoring the northern United States, the Great Lakes region, and the Canadian border states, later in the season rather than the central and southern plains, where activity typically concentrates earlier in spring. None of this means every single unusual weather event on the planet this year traces back to the same omega block sitting over France. It means the underlying current steering nearly all of this weather has become measurably less stable, and a less stable steering current produces more volatile outcomes almost everywhere it touches, not just in the regions currently making headlines. So what does this actually mean for you, wherever you are watching this from? If you live somewhere that has been affected by one of these blocking patterns, the practical reality is straightforward, even if the atmospheric science behind it is complex. Check in on elderly neighbors and relatives specifically, since heat-related deaths disproportionately affect older adults and people with limited access to cooling. Avoid swimming in unsupervised rivers, canals, and lakes during extreme heat, since, as we covered earlier, a large share of this summer's French heatwave deaths came specifically from drowning incidents during attempts to cool off in open water, rather than from heat exposure itself. Pay attention to your local meteorological agency's heat warnings, rather than dismissing them as routine, because the entire point of an omega block is that it does not behave like an ordinary hot spell that will simply pass through in a day or two. And if you live somewhere that has felt strangely unaffected this year, that is not evidence the broader pattern is not real. It likely reflects where the ridge of the omega block happened to settle this particular season, since the flip side of a blocked ridge trapping heat in one region is very often an unusually cool or stormy pattern getting trapped somewhere else entirely, which is part of why so much of this year's weather has felt genuinely unpredictable in both directions, rather than uniformly hot everywhere at once. One more thing worth sitting with before we wrap up. The word block, the term scientists actually use for this pattern, is doing a lot of quiet work. It is not describing a single storm or a single hot afternoon. It is describing a traffic jam in the atmosphere itself, a jam that, once it forms, tends to clear on its own timeline rather than on any timeline, convenient for the people living underneath it. That is part of why forecasters can sometimes see one of these events building several days in advance, since a ridge that is already locking into an omega shape tends to keep doing exactly that until the broader pattern around it shifts enough to dislodge it. But it also explains why nobody can reliably tell you in advance exactly how long a given block will last once it is formed, since that depends on the behavior of pressure systems thousands of kilometers away that are themselves still evolving in real time. The honest, grounded summary is this: the jet stream is not a new phenomenon, and omega blocks are not a new invention of this decade. What has changed, according to peer-reviewed research from Kumho and Kemke, from the Osmond team's millennium-spanning ice core reconstruction, and from the rapid attribution work done by the World Weather Attribution Group this year, is that a warming Arctic is weakening the very engine that keeps this atmospheric river moving briskly and predictably, making the kind of stalled, record-breaking blocks we have now seen 3 separate times this summer alone considerably more likely and considerably more intense once they do form. Nobody Studying this data is claiming to know exactly when the next block will form, or precisely how hot it will get, and any channel telling you they can predict that with certainty is not being straight with you. What the data does tell us, with real sourced numbers rather than guesswork, is the direction this is moving. 3 landmark heat events in a single European summer, a 112s. Year-old weather station breaking its own all-time record, and a leading climate scientist describing a system that is, in her own words, continuing to accumulate heat. We are going to keep tracking this as it develops. Every new block that forms, every station that breaks a record, sourced the same way we did today, straight from the European Center for Medium-Range Weather Forecasts, the World Weather Attribution Group, and peer-reviewed research rather than recycled headlines. Subscribe so you do not miss the next update, because if this pattern reloads a 4th time this summer, it is going to move fast. And leave that comment below. Tell me what the weather has genuinely felt like where you live this year, because behind every one of these numbers is somebody without air conditioning trying to sleep through a 40-degree night, a farmer watching a crop wilt under a sky that refuses to produce a single cloud, a family deciding whether it is finally safe to let the kids swim in the river again. 5,000 likes on this one. Let us go. See you in the next one.